Thank you, David. I'd like to thank the CBRS Alliance, the FCC, the NTIA, all the individuals and companies whose hard work have brought us to this exciting day. I'm honored to be here, and I'm pleased to provide an overview of AT&T's plans for initial commercial deployment of OnGo to provide our next-generation fixed wireless service. AT&T developed its first fixed wireless internet service as part of its participation in the FCC's Connect America Fund program. The Connect America Fund is a program designed to help promote deployment of broadband in high-cost and rural areas. As part of that program, AT&T committed to bring service to living units in high-cost areas in 18 states. We developed our first fixed wireless internet product to help meet that commitment, and that product relied on the use of licensed spectrum, licensed WCS spectrum at 2.3 gigahertz. We will be using the spectrum at 3.5 to help promote our next product, our next generation fixed wireless product. Let me provide you with some information about our plans. Sometime between the end of this year and early next year, we expect to have next generation fixed wireless deployed on 170 sites in Ohio and Tennessee. Over time, we expect to get it on up to 1,100 towers, covering about 82,000 living units in 11 states. Our CAF commitment was to provide service at the level of 10 megabits per second by 1 megabit per second, but with next generation fixed wireless, we are looking at higher speed tiers as well, including both 25.3 and 100 by 20. Let me talk a little bit about our architecture for the service. At the cell sites, we will be using a traditional distributed RAN architecture with massive MIMO. Each radio is a CBRS Class B device. The baseband controllers will be kept indoors or in shelters and connected to the radios by fiber. At the customer premise, we're using a high-gain directional panel antenna with an integrated LTE modem. The antenna is mounted at the roofline and has an Ethernet connection to the router inside the home. The home device will also be certified as a CBRS Class B device to take advantage of the higher power transmission levels, and this will require the use of certified professional installers. In the network core, we have implemented a domain proxy to aggregate SAS traffic, and we have also set up a dedicated SAS APN for traffic between the customer locations and the SAS. Data traffic APNs will not be established until transmit authority has been received from the SAS. We have field testing in progress at 8 sites, which we will soon expand to 16. SAS signaling for both the cell site equipment and the customer equipment has been successfully verified, and using 20 megahertz channels, we have achieved a peak throughput of 140 by 12 megabits at a little over a mile with line of sight to the tower. Our drive testing so far has shown that the RF characteristics of the band are as expected, but we are taking additional testing to further qualify propagation in hilly terrain and dense foliage. We are extremely excited about the prospects of this band. We look forward to its further development and further commercial deployments. Thank you again for allowing me to be here today.